Welcome to a DIY metrology video. In this video, I will be going through the workflow for importing a scan file into the GOM Inspect software, aligning that scan file in space, creating features, as well as sections that you can then export and import those into your native CAD package in order to reverse engineer and model the part. So here I will be using the free version of GOM Inspect 2021. That means I won't have any of the professional features, but that's really not an issue because the free version is extremely powerful. So to start off, I will go ahead and create a new project. And so the first step will be to adjust the GOM Inspect for the particular units that you will want to use. So in order to change that, you can go to Edit and then Preferences. And then so you can select on the left side default units. And for length, I will have it in inches. By default, it's in millimeters. And you can also adjust the decimal places. I'm going to go up to the 4th decimal place because I like to be very precise. Now I will want to import the scan file. And so it's really easy to do in GOM. You can just go through the file browser, open up where your scan file is saved, and drag and drop it into the application. Then I will select a new part. I will select what units the part was saved in. For this particular part, it was saved in millimeters, and for the target element type, it will be a mesh. You can also import just point cloud and also a color mesh if you're using that feature. This particular case, it's just a mesh. So here you can see the part mesh that is in space, and you can just kind of drag around and use your cursor to inspect the scan file. So it will show the gray feature for the mesh with the normal surface. If I look underneath the part, I can kind of see this green to blue cyan color, and that means it is the program is. And so the issue is that if I just imported this particular scan file into a native CAD package, it would locate it using this coordinate system. And that won't really help me out for locating it in space. And so I'd have to manually manipulate it and try to get it lined up to the coordinate system, and so that's not really useful. But I'm going to use GOM Inspect in order to adjust the coordinate system for this particular part. And so to do that, I have to decide what features I want to use to construct a coordinate system. So in GOM, it is really easy to do that. One way to do that is just to go to Construct, Coordinate System, or Local Coordinate System, and then by 3, 2, 1. And so to do that, I will select 3 points in the Z direction, 2 points in the Y direction, and 1 point in the X. And so to do that, let's say I want to use this top face as the Z positive direction to create that plane. And then you can go ahead and create or edit the name. And so this will be named top plane. And I'll go ahead and just add a number to it just in case we added some more. So I will go ahead and create and close. If you use create and close, it just go ahead and closes out of that window. All right, so now we have the first plane created. Now I also want to use some of the side planes in order to create a vertical plane that will go through the center of the part. Now to do that, I'll once again go back to Construct, Plane, Fitting Plane, and then I will select which feature I want to create a plane from. So I will use this particular step, and I'm going to call this vertical plane 1. And then if I use the create button, it will keep this window open so that I can go ahead and just directly create a plane right after. And so once again, I'll hold Control and select which feature I want to create that plane from. And it automatically adjusts the name to 2, and I will create and close. Now this gave me 2 vertical planes, but what I really want is a plane that goes directly between those. And so to do that, I can create construct plane and then use symmetric plane. So here, once again, it pulls up a window, and now I have to select 2 planes to create a symmetric plane from. And so if I wanted to, I could hold Control and select in the viewing pane of which plane I want to use. So I will select vertical plane 2, and you can see that it updated the window to reference that plane. I could also use the drop-down box, and it'll have any of the features created. So now I'll select vertical plane 1. And if I hide that mesh, I can see the preview of where that center plane is created. So you can see from acute angle, it's generating that plane exactly how I'd like. If I uncheck that box, it will create a flat plane, essentially where these 2 planes would intersect, which is likely infinitely far away. So if you see that your plane isn't being generated where you expect, go ahead and check that box. And it's going to name this center plane 1, which that works, and I will create and close. Now I want to pull up my mesh again. So in the Explorer browser on the left-hand side, I will go ahead and just click on the visual icon there, and now my mesh is shown. Now, finally, I need to create a center location for this part, and so I'm going to use one of these cylindrical features. And so I'm going to use one of the lower cylindrical features just because it will have a lot more data for me to extract, so it will likely be much more accurate. So now instead of going to plane, I'm going to select cylinder, but once again go to fitting cylinder. Here's the window with some settings that can be adjusted, but these should get you for most of your applications. And so I will hold Control, select the cylindrical feature that I want to create a cylinder about, and just select. So now it'll think about it, it'll show the data that it selected that it thought matched the cylinder. And then if I scroll and look at the other side of the part, you can also see that it highlighted that data, so it was able to intelligently detect that all of this data should match this particular cylinder. So it's named cylinder 1, so I will go ahead and create and close. So now I have all of the features that I want to use for creating this particular alignment. So I am going to hide a couple of the features that I won't be using. And so to create my coordinate system, I will use the shown features. To do that, I will go to construct local coordinate system by geometric elements. And so now I will need to select 3 elements to create that coordinate system. So once again, you can hit Control and then select the feature in the window, and it will automatically update it into that next particular icon, or I can select it from the drop down for cylinder 1, and then the final element will be that midplane or center plane. And so here you can see the coordinate system that it is constructing. And so I want my top plane to define the z positive direction. So when I change orientation mode, it might be an automatic, and then you can just select that to manual, and then you can define your coordinate system from there. So this looks good for me. It's going to name it automatically based on the features, which that works, and I will create and close. So now I have a coordinate system defined by my part that matches up directly in the middle. But if I selected the viewing icon, it still hasn't oriented the part correctly because it's using the main coordinate system that it came in with. And so now I want to move this part to the coordinate system of GOM Inspect. So to do that, I will go to Operation, Alignment, Main Alignment, by Coordinate Systems. Here's the window that pops up for the alignment. I will select the target coordinate system, which is just the global coordinate system. Now the actual coordinate system is the one that we just created. And so once I select that, you can see that it shifts the mesh to the global coordinate system. Go ahead and click OK. And now when I select on the viewing system here, I can see that my part is perfectly aligned. So now all I need to do is create some sections for the part that I can export to my native CAD package for quickly reverse engineering. So to do that, I'll go to Construct, Section, Single Section, and I will select which particular plane I want. So for this one, I want to create a section in the X-plane at 0 location, and then here's the preview that shows. And then in order to actually create this selection, you have to select the mesh. So right click on the part and select all points of elements. And now I can see the line that it is creating for that section, and I will go ahead and create. I will do the same thing for the Y plane, so I can get all of those cylindrical features imported into the CAD package. And once again, right click and select all points of elements. Now I will create. And so the final section that I want to create will be to locate these holes in the part. And so to do that, I'm going to create a section in the Z plane. But by default, it will be at the top position. So I actually want to lower the section plane so that it actually intersects with the holes of the part. So to do that, I will just go on position and I can manually adjust that. Or I can use the scroll wheel to quickly move it down the part. And so a tip is that if you hold Control and use a scroll wheel, you get a much finer increment so that I can really dial in where that section will be taken. So I'm going to take this section about 40,000 inches below the Z plane, and then I will select all points of the element. And now I get the preview, which that looks great, and I will create and close. Now I can export all those sections. So I will go to the geometries viewer, select sections, and here I can see all of the sections that got created. So if you select a section and drag it into the window, it will exclusively show that. So now I can only look at that section. And so here is the section that it got created. Now, if I want to export this section, I will select the particular section and then go to File, Export, Geometry, IGES. And so now it's going to have a window so I can save it to a particular folder with a particular file name and adjust the units if I want. Now I'll just hit OK, and I'll repeat that for each of the sections. So now if I open my file browser, I can look at each of those exported sections, and now I can put those into a CAD package and quickly reverse engineer this part. Now if you also wanted to export the scan file that has been oriented in this coordinate system, all you have to do is select your mesh so that it's highlighted, and then go to File, Export, Mesh, and then you can decide what file format you want it to be exported in. For STL, object file, poly file, and so I will export it as an STL, and then have it go right to my default location, and I'm going to export it in inches. And so here is that new file that I can open up that is properly oriented and saved as an STL. Thank you for watching. I hope you learned something.